Alright, in this video, we'll be talking about resolution of vectors and what vector resolution is all about. Now, basically, resolution of vectors or resolving vectors simply implies breaking down the vectors into their horizontal and vertical components. It simply involves breaking down the vectors into their horizontal and vertical components. That's if you have a vector, for instance, in this case, this is a vector A, all right? Remember, vectors have magnitude and direction, so we use arrow to indicate the direction. So let's say you have a vector A, and then you're told to resolve it into the horizontal component. That's to say, make this vector A seem like it's acting on the horizontal, all right? Or you're asked to resolve it into the vertical component. That's make it seem like it's acting on the vertical. That's what resolution of vectors is all about, all right? Break down the vector into their horizontal components and vertical components. Now, to resolve a vector horizontally, we use cosine, all right? Cosine or cos. Now, to resolve a vector vertically, we use sine, all right? Now note, this is applicable only when the angle used in resolution is the angle the vector makes with the horizontal. Of course, you can use the angle with the vertical to resolve vectors, but the method I'm about to show you in this video is only applicable for a situation where the angle the vector makes is with the horizontal. Alright, so you only use this method when you're using the angle the vector makes with the horizontal. So in the case whereby you're giving angle with the vertical, you say 90 minus that angle with the vertical to get angle with the horizontal, right? So that's when we only use this. To resolve a vector horizontally, we said use cosine. To resolve a vector vertically, we say use sine. And then this is applicable when the angle used in resolution is the angle the vector makes with the horizontal. Example here, we have vector A. If we want to resolve vector A into the horizontal component, come down here, we say horizontal component of vector A, horizontal component. Now we want to resolve this guy horizontally, make it seem like it's acting on the horizontal. So say horizontal component, this will be equal to A, the vector, and then we say cos. Remember, we say we resolve vectors horizontally using cos or cosine. So say A cos theta, all right, which is the angle the vector makes with the horizontal, all right, A cos theta. So that's the formula. Now for vertical, to resolve a vector vertically, you say A being the vector sine theta. So it's just the magnitude of the vector sine the angle it makes with the horizontal, all right? To resolve a vector vertically, we said A being the magnitude of the vector sine the angle the vector makes with the horizontal. All right, for both cases, we use angle with the horizontal. Don't forget, this is for vertical resolution, you use sine, and then for horizontal resolution, you use cos. So say A being the magnitude of the vector, as we have here, cos theta. Theta is the angle with the horizontal. And we are using cos here because we are resolving horizontally. Vertical here, we are using sine because we are resolving vertically. So we have magnitude of vector sine the angle vector makes with the horizontal. Please take note, for both of them, we use angle with the horizontal for this method. So this is the formula for horizontal resolution, and this is the formula for vertical resolution. Now here is an example. You have a single vector here, and the magnitude of this vector is 5 meter per second. So let's say this is a velocity vector. So we have v. Now they say resolve into horizontal and vertical components. So we can denote our horizontal. So we can denote our horizontal component with x. So we can say v of x being horizontal component. Okay, horizontal components. Now to resolve it horizontally, we say the magnitude of the vector cos the angle it makes with the horizontal. Don't forget the formula. The magnitude of vector cos theta. Theta is the angle vector makes with the horizontal. And for horizontal resolution, we use cos. So say v of x equals 5 cos 30. We have 4.33. So you can see this will be equal to 4.33 meter per second. And then for vertical resolution, we have v of y. I want to resolve this vector. into the vertical component. So our v of y equals the formula again. We say magnitude of the vector. Since we are resolving vertically, we use sine, and then we use the angle the vector makes with the resultant. So we say 5 sine 30, and that will give you 2.5 meter per second. All right, so this is your answer for vertical, and this is your answer for horizontal. Now, in some cases, you may have more than one vector acting at a point. Like in this case here, we have vector A, vector B, and vector C. We have three vectors acting at a point. If you read this question, example 2, they said in the figure above, A is equal to 20 cm. So this is like displacement vector. All right. So A equals 20 cm, B equals 40 cm, and C equals 20 cm. They say find the magnitude of x and y components of the resultant vector expressed in unit vector notation. Find the magnitude of the x and y components of the resultant vector simply implies resolving the vectors into their x is horizontal and y is vertical components. So basically, they're asking you to resolve into the horizontal and vertical components first, and then you express your answer in unit vector notation. All right. So to do that, it's very easy. We have, unlike the case we looked at before where we had a single vector, here we have three of them. How do we know the vectors? You always see the arrow, all right? Talking about direction, magnitude and direction, that's vectors. So you see the arrow, all right? Anywhere you see an arrow, there's a vector there. There's a vector here, there's a vector here, there's no vector here, there's a vector here, there's no vector here, there's no vector here. And also you see the magnitude most times written close to the vector. So here we have three vectors. How do we go about it? It's very easy. All you need to do is resolve each of them. All right. You start with this one, resolve into the horizontal and vertical components. Though this guy just exists on the vertical, so we can ignore the horizontal. But for this method, I would say still resolve into the horizontal and vertical components. You go to the next vector, vector B, resolve into the horizontal and vertical components. You go to vector C, resolve into the horizontal and vertical components. So basically, you can take horizontal component first, resolve all of them horizontally, add all the horizontal together. That is resultant magnitude for x components or horizontal components. You resolve all of them vertically again. That's for vertical components. Get your answer and then add up everything. That will give you resultant for vertical components. So we're going to do it together. But before we do that, there's something we call the cast principle. And then I will also talk about this. Now let's start with the cast principle. Now basically we have four quadrants. This is first, this is second quadrant, this is third quadrant, this is fourth quadrant. So this is cast principle. Now what this means here, in the first quadrant we have A. A means all. All right, that's to say all trigonometric identities, sine, cos, and tan. All right, all of them, that's to say sine, cos, and tan. All of them are positive in this quadrant. So anytime we have a vector falling in this quadrant, that's in this space here, all right, between this line and this line, we have a vector falling here. Whether we are resolving vertically, that's using sine, or resolving horizontally, that's using cos, that vector is going to be a positive vector. It's going to be positive. All right. Now, in the second quadrant, we have S. S here stands for sine. All right. That's only sine is positive in this quadrant. That's in this space here. Only sine is positive. So if we have a vector falling in this space between this line and this line, just in this space here, that vector, if we are resolving vertically, that's using sine, the vector is going to be positive. But if you are resolving horizontally, that's using cos, the vector is going to be negative because only sine is positive in this quadrant. Now, if you come to this quadrant here, we have t. All right, t here stands for tan. All right, that's to say only tan is positive in this quadrant. So if you have a vector falling in this space here, between this line and this line, just in this space, that vector, if you're resolving vertically, that's using sign, the vector will be negative because only tan is positive. If you're resolving horizontally, that's using cos, the vector is also going to be negative. And of course, we don't use tan to resolve vertically and horizontally. All right, tells you that whether you're resolving vertically or horizontally in this quadrant, your vector is going to be negative in third quadrant. Now here we have C. C here stands for cos. That's to say only cos is positive in this quadrant. All right. So if you're resolving vertically, that's using sine, the vector will be negative. If you're resolving horizontally, that's using cos, the vector will be positive. So that's what cast principle is all about. Now let's come to this case here. Remember previously here we were just talking about the spaces, the quadrants. We didn't talk about the axis. Sometimes the vector can fall on the axis, horizontal axis or the vertical axis, just like we have in this case here. Our vector falls on the vertical axis. All right. So in a case whereby the vector is not in the quadrants, but it falls on the axis, how do we go about them? Now on our Cartesian plane, that's vertical and horizontal. We have up here from the origin to this point here is usually positive. This is like your y-axis and this is like your x-axis. So from here to here is positive y-axis. So if a vector falls here, all right, like in this direction, that vector is going to be a positive vector. Now here is our positive x-axis. So if a vector lies here, that vector is going to be a positive vector. Now here is our negative x-axis. If a vector falls on this line and pointing in this direction, that vector is going to be a negative vector. If a vector falls here and pointing downward in this direction, that vector is going to be a negative vector because this is negative y-axis, negative x-axis, positive x-axis, and positive y-axis. So in that case, it simply means this vector A here is going to be a positive vector. So with this now, we can now resolve this vector. So like I said, we resolve horizontally, all right? We find the horizontal components. Then when we are done with that, we add all the horizontal together, get the resultant, go to the vertical component, add everything, resolve everything, and then add up. So let's start now. So we'll start with horizontal component. Horizontal. So let's start with vector A. We resolve vector A horizontally. Now first, remember our formula for resolution of vectors. Magnitude of the vector. If we're resolving for horizontally, we use cos. Then we'll say cos the angle the vector makes with the horizontal. So let's see. A is our vector. What's the magnitude of A? We have 20. You can see it here. A equals 20 cm. So we have 20. We are resolving horizontally, so we say cos. Now, what's the angle vector A makes with the horizontal? This is our horizontal here. From vector A to the horizontal, you can see they are perpendicular. All right, they are perpendicular. Vector A is perpendicular to the horizontal. So and as such, we say the angle it makes with the horizontal is 90 degrees. So vector A, we're going to have 20 cos 90. And that will give us 20 cos 90. And that will give us 0. So that's to say vector A does not exist horizontally. So in some cases, or in most cases, you see some persons when they solve, they'll say you cannot resolve vector A horizontally because it's on the vertical. That's very much correct. So you ignore, right? But in this case, I just want to do everything. Let me just show you how you're supposed to do it. All right. Now, vector A, remember, falls on the positive x-axis. So it's positive. All right. So that's why we didn't bother putting any sign here. So that's what we have here. So this is vector A. Now you go to vector B. Vector B. Again, what's the magnitude of vector B? 40. We are resolving horizontally, so we use cos. Now, what's the angle vector B mixed with the horizontal? We have 45. This is vector B. This is the horizontal. The angle it makes with the horizontal is 45. So we have 40 cos 45. That will give you 28.28. But before we continue, remember this quadrant is our first quadrant here. Let's see if vector B was supposed to be a positive or negative vector. It's our first quadrant and all are positive. We are using cos here, right? So it simply means this is going to be positive. So that's why we did not bother to put any sign. All right, if it's to be negative, you must add this sign. So we have 28.28 cm. Now you go to vector C. Resolve horizontally again. We're resolving everything horizontally first. So we have vector C. What's the magnitude? 20 cm. So we have 20. Since we are resolving horizontally, we use cos again. Now, what's the angle vector C mixed with the horizontal? This is our horizontal. You can see here is 45 degrees. So we have 20 cos 45. And 20 cos 45, that is 14.14 cm. Alright, so that is it. Now you can see vector C falls in the fourth quadrant, and in the fourth quadrant only cos is positive. Alright, so that's why we don't bother putting any negative sign here, we'll just leave it that way. So we are done with resolving horizontally. Alright, so now let's get our resultant for the horizontal component. To get the resultant, when you're done, you add up everything. Okay, so we have 0 plus 28.28 plus 14.14, and that will give you 42.42 cm. So this is our horizontal component. So we can record it down here. Rx equals horizontal component of the resultant is 42.42 cm. So now let's try to get the vertical component of the resultant. Remember they said find the magnitude of x and y components. X is horizontal, y is vertical of the resultant vector. So this is for horizontal. Now we'll go to vertical. The only difference for vertical is that rather than having cos for vertical, you'll be having sine. All right, so let's do it together here. So now we want to resolve vertically. So come down here, see vertical. So take them one after the other again. We come to our first vector. We can take A first, can take B first, can take any one first, but just apply the principle. So we can start with A, vector A. All right, these are the points where we have vectors. There are no vectors here and here, so there's nothing to resolve. Okay, so vector A, what's the magnitude of vector A here? We have 20. Do not forget the formula. Magnitude of the vector, since you're resolving vertically, you say sine, then the angle the vector makes with the horizontal. So say 20. Now A, what's the angle it makes with the horizontal? You can see from here down to the horizontal, right? They are perpendicular, and the angle is 90 degrees. So say 20 sine 90. Now A falls on the positive y-axis, so the vector is positive, so we don't attach any negative sign here. So we have 20 sine 90, and that's equal to sine 90 is 1, so 20 times 1, that's 20 cm. Now go to the next one, vector B. What's the magnitude of vector B? The same principle, all right? Vector B, what's the magnitude? We have 40. We're resolving vertically, so we have sine. Now, what's the angle vector B mixed with the horizontal? We have 45 degrees. Don't forget, in this method, whether you're resolving vertically or horizontally, we use angle with the horizontal. All right? So we have 40 sine 45 degrees. Vector B, this is the angle it makes with the horizontal. So we have 40 sine 45, and that's going to give you 28.28 cm. But before we conclude, this quadrant is our first quadrant, like we have here, and all of them are positive. So since we are using sine, sine is positive, so we are now attaching a negative sign here. Now let's come to this quadrant, vector C. What's the magnitude of vector C? We have 20. We are resolving vertically, so we say sine. Now, what's the angle vector C mixed with the horizontal? We have 45 degrees. So say sine 45. Now, this quadrant is fourth quadrant, and in this quadrant, only cos is positive, and here we are using sine. So it simply means this vector is going to be negative. So we'll attach a negative sign here. If it were to be positive, we don't attach any sign here because that's what positive simply because when you don't attach any sign, it's the same thing as saying it is positive. All right, it does not have any sign, it's the same thing as saying it's positive. But if it's negative, you must put a minus sign. So you can see in this case, this guy here is in the fourth quadrant, and we are using sine in this fourth quadrant. All right, and sine in the fourth quadrant is negative because only cos is positive. So we'll put a minus sign here at the back. So we're going to have minus 20 sine 45. And that will give us minus 14.14 cm. So now we add up everything together to get our resultant for vertical component. So say resultant for vertical component, that will give us 20 plus 28.28 plus this guy is minus 14.14, and that will give us 20 that will give us 20 plus 28.28 plus minus is minus, so we just put minus 14.14, and that will give us 34.14 cm. All right, so the resultant for vertical component is 34.14 cm. So we record it here, 34.14 cm. Now the question said find the magnitude of the x and y component. This is for x and y component of the resultant vector. So we have done that. Now the next part, they said expressed in unit vector notation. Now they want us to express it in ijk components. All right, that's what unit vector notation is all about in their component form. Now in ijk components, we usually use x for I component. X represents I component, Y represents J component. Okay, X for I component, Y for what? J component. So in that case, if we want to write this resultant here in IJK components, all right, or in unit vector notation, X, like I said, represents I component. So write 42.42 I. Okay, X is for I component. They will say plus Y is for J component. So say 34.14 J. This becomes our final answer. So that's how to resolve vectors into their components, and also you can represent it in this form.